Hey everyone, I am Rivu Chakraborty. Today I will be talking about optimizing UI in Jetpack Compose. This talk will cover structuring your UI components, how to optimistically structure it, along with some performance optimizations and what is composable and what is recomposition and all those things, right? So here's a little bit about myself. So I am a GD for Kotlin. I happen to be India's first in this category, and I have been in industry for more than 11 years now. Currently, I'm working as a mobile come Android architect at GeoCinema, where I work with performance optimizations, DevX, and I work with basically the mobile platform team, and yeah, along with a lot of other things here. Uh, I previously worked with multiple other unicorns from India and Southeast Asia that you can see here. I wrote few books in Kotlin and Android, and I uh, try to, or I like to mention myself as a community person. First, what is composable? Now, this is a question for live audience. I please feel free to comment in YouTube. What do you think is a composable? I will give you a few seconds to comment, and then I will continue. I can see the comments, by the way. I have it open in a different window. Okay, I don't see any comments on YouTube. Okay, smallest compose component. But what is at that composable? Uh, if you have any idea of what is at that composable is. So, okay. Whenever I ask these questions at various conferences or when talking casually to other uh, industry people, uh, yeah, it is a Kotlin function that is supposed to draw UI, but it has more to it. So, yeah, whenever I ask this question to other people, what I mostly hear is that it's an annotation processor, which it is not. It's not an annotation processor. So compose other composability works more like how suspend works, right? Or how at the rate serializable works. These are language keywords. Although they looks like an annotation processor, these are not annotation processors. These are compiler plugins, which works like a language keywords and then generates a function, right? So annotation processor can only generate code, cannot modify any existing function, or cannot write new code, right? It can write new code within the generated code, but it cannot modify the existing code or rewrite existing code, right? So that's the limitation of any annotation processor, where compiler plugins come in and at the composable works in a similar way. So here we have an example. Here you can see that I have a function blue text, and it's a composable function. And here's the modified version, what at that composable does to it. So it injects something called composer in the function, and then modifies the function to start the composer and end the composer after the function content, right? Uh, Here I have a screen that is supposed to recompose whenever the state changes. I am observing the state with viewModel.state, and let's assume that's a mutable state. And yeah, whenever that state changes, the composable should recompose, right? And that's how it works. Again, now composer starts, we observe to the state, and uh, then our code goes, right? Uh, Now, what is composer? Composer, we call that a calling context object, and it's responsible for composing and decomposing the composables. And its actually implementation details contains a gap buffer. Leland Richardson has very good talks on it. You should go and check out. the talks by Leonard Richardson on what is composer and how gap buffer is used to store composables, right? Uh, Now, what is recomposition? We talked about what is composable, and we mentioned something recomposition, right? Uh, what is recomposition? Recomposition, you can think of it is a recursion with update parameters. So we all have wrote recursive functions, right? Sometimes in our career or in college or in while working as well, right? Now, what it does is that, let's take our previous example only, where composer starts, and when composer end, it adds a little bit code to it. So you can see here in the update scope section that if something changes, it calls the function again with the next composer, right, with the update composer, and then it composes the function again and runs it. Now, there are phases of compose. I talked in brief about what is composable and what is recomposition, but there are more nuances to it. So these phases of compose are called composition. Basically, there are three phases. They are called composition, layout, and drawing. This bit sounds similar to how view is drawn in XML as well. XML views are drawn in Android as well, right? So there is also measure, then draw, and more steps. It sounds a little bit of similar. Yeah, recomposition is not necessarily redraw. I will come back to that when talking about three phases of compose. But yeah, it's basically it calls the same composable again with updated parameters as I shown earlier. So yeah, these three phases of compose look similar to views, how view works, right? But there is a difference. So for view, every child view. So if you have a parent view and inside that you have a child view, then these three phases will be uh, drawn for the will be done for the parent view, and then for the child view, and then again for the parent view. So it's recycling, right? However, that's not the case in when it comes to compose. It's basically in the composition layer. Let me first talk about how it works. So in composition layer, it goes through all the composables you have in your code, including at that composable functions and at that composable lambdas that you might have, and it turns those into nodes, right? For example, column takes a lambda, right? At that composable lambda that should contain the children. So you can see that at that composable, the composition phase runs once and generates the nodes from the composition. I have a video for this as well. This video is taken from here, developer.android.com/jetpack compose/phases. So yeah, here you can see that how it draws the nodes in the composition layer. After composition layer, there comes the layout layer, which takes those nodes and then runs the measure, and then draws the or sets up the boundary for UI, right? It doesn't draw it; it sets up the boundary and measures it basically. And after that layer comes drawing phase. So in this phase, it draws the UI within the measured layout. So the difference. What happens here is that if you have a modifier dot background, then background color is drawn here. Canvas, if you are doing something on canvas, drawing something on canvas, that is also done here. Similarly, if you have text, that text is also drawn here. Now, so these are the state reads. So at the composition layer, as I said, all composition composable functions and composable lambda blocks are read and then created the layout node. And then in the layout, it measures the lambda, and it works with modifier.offset, modifier.padding. All those are measured here. And then layout boundaries are set. And on the drawing layer, it works with canvas, draw background, draw with content, text, etc. Now, whenever recomposition happens, composable is actually very smart. It doesn't execute all the steps unless necessary. So, whenever the recomposition happens, if the content is not changed, then composition phase is skipped. It if it only works with layout and sizes, then only layout phase is rendered. If content is not changed, then composition phase is skipped. Similarly, if the size or position has not changed, then layout phase is skipped. And only if the say background is changed, then only drawing phase will execute. Right. So composable is smart in this regard. Now there's something called recomposition loop, right? So here we have a function that's called auto resize text. That basically the like you can pass max lines here, and if your text goes beyond those max lines, then the text will auto resize it. Right, instead of ellipse size, it will auto resize the text size, and it will show some text. Uh, this code I found in one of my friends' code base who was working with a client as a freelancer, and he showed this code to me. This is not a very good code, and we'll try to go through the code and like figure out what the issue is, right? So here we have a mutable state which basically keeps a loop of the text size, right? So default text size is the text size that is passed to the to this function here, and it uses it keeps it as a mutable state, and then it passes the mutable state here on text size. Font size equal to text size, which is a text unit, right? So yeah, and then what happens is that on text layout, it basically remeasures the text size. So it checks that if current line count is more than what is specified here, and yeah, then it basically, if the line is ellipticized, then it basically reduces the text size. Let's assume this is a constant where it's say 0.8, 0.9, something like that. 90% or 80% reduction happens, and when this reduction happens, what will happen is that it will reinvoke the reader, and this frame will be running again and again. It will continue until it reached the point where it's only like it's according to the max line, right? If we said max line is equal to 1 and text was too big, it will keep reducing the text size until it has reached max line equals to 1 according to the code, and this thing will keep happening and happening again. So this is a recomposition loop, which can be a performance issue. Okay, I hope everyone can hear me. My mic says it's good enough, but yeah. So yeah, this is what recomposition loop is. Now let's try to figure out how to break down composables, right? So let's say we have a screen like this, right? Uh, this is a typical profile screen in any app. This is if you start with Figma, then this is the default app design that you will find with Figma, and I just took the profile screen from that. Right, this is a typical profile screen with a bottom navigation, and then there is a list of posts, right? So one way of creating this is like this, where you have one composable function that does everything. So It has a lazy vertical grid, and then you add items. Like one item would be the profile image, then the profile name, profile location, but follow button, and message button, and all those, and then items of posts. Right. This is one way of doing it, which is overloaded. And if you want to do something different on the buttons, then let's say you have some state, right? That if you are following, then the button instead of saying follow Jane, it should say unfollow Jane. And then if you are observing it with state, then your entire composable block will depend on that state, and you will end up with a pretty unoptimized code. So in order, you should avoid doing this, and that's why the text size is too small, because I just wanted to show what is a bad practice, and I didn't want anyone to actually uh, follow this. Yes, I am talking, and I hope everyone can hear me. Okay. Yeah. Now this is a better way. So we should break it down. This is the profile screen where one of the item would be profile section, where you will see all the follow Jane, message button, and profile image, and location, all those things. And then there will be another section for post list, and you can do it like this, right? Profile section will be like this. So there will be profile photo, which is a separate composable altogether, and then name and location, you can keep it as text. And then there will be follow button and message button, where you are passing the profile ID, and you can observe the state here that if the user is following them, then text will be different, right? So yeah, this is how you should break it down, and that will not only increase readability of your code, but it will also increase or decrease the performance bottlenecks, right? Now, state hoisting. State hoisting is a term that sounds complicated, but really it isn't, right? So let's say first start by defining what is state, right? So let's say we have a movies app, and we want to observe the uh, list of movies, and yeah, this is the state for it. It's simply a data class where if you have done some query, the query would be there, and then there's a list of movies, is error, is loading, and detail, like that, right? And yeah, and then you observe the state by either using live data. If you are using live data, then this is how you observe as state, or you can observe the state from view model as a mutable state as well. You can use state flow or shared flow. However, the code will look something like this in your composer function, and you will observe the state, and yeah, then your UI will be defined by it. So what is state? State is basically the definition of what is shown in your UI in a data or in a class format, right? So what is here in this data class, the values that should be exactly represented in your UI. Uh, and what is state hoisting? Now we know the what is state. What is state hoisting? State hoisting is that how to basically or where to keep the state, and that is basically, this is the definition of state hoisting, where you have a UI logic, and you decide on where to keep the state based on the based on your requirement, right? So you can either leave the state internal to composable, like what we are doing here. Here we have a swipe refresh state, and we are keeping that state within the composable, and that composable will appear as a stateless composable to whichever composable is using this show list. So swipe refresh state is maintained by show list composable only, and whenever swipe refresh is triggered, it triggers a function on refresh function, and that is basically a stateless composable, right? Or you can keep the state with view model, And like this, you can observe the state and you can do some actions based on your state. Or here, how we are calling the my form. So basically you can basically pass the state to uh, your composable, and you can update it there as well. That is how, if you look at it. So let's go back to swipe refresh. And yeah, this swipe refresh state, that's how it works, right? So yeah. uh, Now let's continue to side effects. So what is side effect? In functional programming, side effect is something that you call when or that happen that doesn't have direct relation to your function output, but yeah, that you call during your function body, right? So sometimes you want to call it only once, sometimes you want to call multiple times. For example, logging or analytics, right? Those are also side effects. When it comes to UI, however, uh, you sometimes want to call an API whenever your UI is loaded. Right? That is also called an side effect. Or sometimes you want to trigger analytics events whenever every time your screen is recomposed. That is also a side effect. Yeah, here is the definition of side effect from composables. So yeah, you can go through that. And yeah, it basically lets you you or it basically exposes some very good APIs which you can use to trigger side effects and to manage side effects basically. Uh, First of the side effect is launched effect, right? So here we are using launched effect. So whenever this add item query is updated, we are this launched effect actually takes a key. So if the key is changed, then only this block will be executed. Unless this key is changed, this block will not be executed. So here we are taking add item query, right? Again, going back to the form screen. And whenever user adds some text to it, then this item would be updated. And once the item updated, it will come here. So every key press, it will come here. And if it is blank, then no need to do anything. The logic is here that what to do whenever this is updated. So if it is blank, no need to do anything. We are returning it. Otherwise, we are using delay here. So launch effect also comes with integrated coroutine scope support. So delay is working as a debounce effect here. So we are actually waiting 500 milliseconds before calling our APIs or before calling vmodel.add item. So basically, you have probably done that a lot of times on search as well, right? So whenever search query is updated, we add a debounce effect before triggering auto search. Right? It is similar behavior here. So we are having a 500 milliseconds rebounds effect before triggering add item. Right. So this is launched effect. Then there's disposable effect. Disposable effect also takes a key, which will be like it will be this block will be called only when the key is changed. And however, disposable effect doesn't come with coroutine integration, so you have to use coroutines by your own, right? Now there is a difference between disposable effect and launched effect, although they both work if the key is updated. Disposable effect lets you or gives you an API for disposing of it. For example, you are calling viewModel.load items on your screen, right? Now with launched effect, what will happen is that if your screen or if your UI is no longer in view, uh, your view model will still execute load items because you have not cancelled that job. Uh, However, that will not be reflected on UI, right? However, if you believe there is a lot of computation on viewModel.load items and you want to cancel that job whenever you don't require it anymore, then you can use disposable effect where you can return a job from viewModel.load effect load items, and on dispose you can call job.cancel, so that job will be cancelled. Now notice here that we are passing unit as a key, right? In launch effect we were passing something else, not unit. You can pass launch unit in launch effect as well. Yeah, what we are doing in disposable effect, what it does is that it will run only once for your composer. Until the calling context is changed, this effect will run only once, and no matter how many times it's recomposed, this effect will not be executed multiple times, right? This is a very crucial thing when you want to or very important thing to do when you want your APIs to be called only once. Say you are loading something from API, then you can use launched effect or disposable effect based on how you want to do that, and yeah, you can use that in that way. Like Zeus, I will answer the scope related question at the end of the session during Q&A. Yeah. So that's how the disposable effect and launched effect works. And yeah, now let's move on to the third one. So this is side effect, right? So sometimes you don't really care that it is getting called as only once or twice. You want to basically run it every time the screen is recomposed, right? Probably you are keeping a tab on how many times the screen is recomposed or something else. So in those cases you can use side effect. Side effect doesn't have a key, it has a block that will be called every time the screen is recomposed. And sometimes it's useful for analytics, but sometimes you in analytics as well you want to do it only once. So in those cases you should use launched effect or disposable effects, right? So yeah, uh, this is the effects. Here what I said about launched effect. So yeah, I am let's do something here, right? So we have a text here, and based on the state value, we are either showing loading or log out. Basically, if the user is logged in, then we are showing some loading, or on success we are showing some UI. If the user is not logged in, then we are calling logout function that will basically navigate the user back to the login screen, right? And we are returning an empty text, right, in the text. However, this will not behave properly. Uh, this is a better way to do that. Why? Because this will trigger multiple recompositions and your logout will be called multiple times uh, because your state is changed. And as the state is changed, it will call logout. However, on logout, your state will change again, and that will trigger multiple recompositions. In order to avoid it, we can use launched effect. So that we are also separating the concerns. So calling logout is not the part of this when logic where we are showing the data, right? So for showing data, we are doing what we were doing earlier. However, logout is we are using remember to remember the state value, and we are if the state is not logged in, then we are calling launch effect to call logout. However, this code still has a issue. Anyone can identify what the issue is in this code? A few seconds for comment before I move forward. If anyone can identify any issue with this code, and I left it intentionally. Okay, no comment. So let us move forward. So let me first tell you what the issue is with this code. So we are using remember, which I will be covering in next section. But what will happen is that this state value is logout will always no doesn't we don't need to cancel anything here. So what's happening is here the issue is here. So let's assume the initial state value is loading or success, right? So is logout is false, and what will happen is that this value will never change. because we are remembering this value, right? Initial state value. And whenever the state changes, it will not re-execute. Why, I will cover. And that's why on logout will never get called. Now, why it will not be called, right? Why the value will not change. Before we understand that, let us understand what is remember. So remember actually lets you remember a value even if the recomposition happens. You are still remembering some state, right? That's where remember comes in. Uh, Now let's try to understand this by this code. So let's assume uh, we have a list and we are sorting it, and then we are using that list somewhere, right? What will happen is that every time this composable is called, your items will be sorted, and that will lead to your performance bottleneck, right? One way of doing this is to remembering it. Now, you will see I am passing some value here, state.items in remember. Uh, why? Because remember is also key dependent. You can pass a key that this block should be recomposables or your state should be recreated only if this value is changed, right? Your key is changed. Then only your state should be recreated. So that's why that block will not work, because we were not observing to the state in the remember. We didn't pass any key to the remember. Now, what it does is that it creates a mutable state of items. It sorts the item and creates a mutable state of it. And no matter how many times this show list function gets recomposed, unless the calling context is changed. What do I mean by calling context? Let's say this show list is called from two separate composables in two separate sections of the app, right? So in those cases, the calling context is different, because composer pass for first section and composer pass for second section is different. Or for some reason, you're calling the composable where you are calling from the show list itself is recomposed. In those cases, calling context will be different. So in those cases, your state will be recreated, but yeah, unless the calling context is not changed, remember will remember this state value. Until this state dot items is also changed, right? So yeah, unless calling context changes or your key changes, remember your state value no matter how many times your composable recomposes. So that will save you some performance issues here, right? And that will help you remember, like whenever state updates, you can remember that this was the last value. And otherwise, if you don't do that, what will happen is that every time this value will reinitialize. So that will not happen here, right? So yeah, this is remember. Now there are some things, these are to help you recomposition, right? At that stable and at that immutable, what do they do? You have probably heard of them, but let's try to understand what they are. So let's assume you have a data class, right? Uh, Address table is actually to communicate. Most of the time, you don't need to use those. Those are basically composable. Is pretty smart. It can detect when your state data class is does not is stable enough, and does not need recomposition multiple times, right? What happens with other stable annotation is that, let's say you are using some complex data types that let's say you have a byte array in your code that composable cannot determine if that changed or not, right? So in those cases, at the stable helps. So it is basically to communicate to the Compose compiler that if something changes in this state, then we'll communicate with the APIs provided by the Compose compiler in a certain manner, right? So let's say, and this is the definition of immutable, where it says that nothing in this function will change. Nothing in this class will change. And if something is changed, your state itself will be updated. This instance of this class, in this instance of this class, nothing will change. And this is the formal definition for both of these. You can look through these, but what adjuster says is that in this instance of the class, if in this instance of the state, if anything is changed, we will communicate through APIs. And what this immutable says is that in this instance of the state, nothing will change, right? So here's at that immutable where we can have a data class, everything is val, so nothing will change. And if you want to change something, we'll use the copy function, which will basically which creates a new instance of your data class, right? That's not the same instance. And we'll pass it to the state. And so we are basically saying state is updated. And at that time only composable should recompose, right? And here's the definition. Here's the description of address table, where we have a var background color, but that uses a mutable state of. So whenever that is changed, composable will know, because we are using a mutable set of provided set of API, right? So yeah, these are at their immutable and at their stable. Now here is something interesting. So what happens whenever you probably have seen this when I was talking about, remember I was using two immutable list at one point. But what is immutable list and why does it matter? So immutable list comes as an separate package with Kotlin X collections immutable package. And what happens is that lists are considered unstable. So although there is list and mutable list provided by Kotlin standard collections API, lists are not necessarily immutable, even if you are using list instead of using immutable list, right? You can cast a list to immutable list. You can cast a list to mutable list anytime, and you can update the contents of it. And it's not possible for the compose to track that whether the list is stable or not, because any list can be cast to mutable list. To solve that problem, this immutable list or Kotlin collection X immutables comes in. So here we are. This is the again same code where I showed how to use remember. Here you can see two immutable lists, right? So what it does is that it converts this list to a immutable list, which is a separate structure altogether, right? And it cannot be casted to a mutable list. So Kotlin compiler can guarantee composable that, hey, this is a immutable data structure, and nothing in this data will in this list will change without updating the state itself, right? So in that helps you removing or reducing recompositions when dealing with lists. Now, we talked about a lot of ways you can reduce recomposition, lot of ways you can optimize your performance. Now, let's talk about checking performance. One of the ways is to use layout inspector, like how I showed here. It shows recomposition count here. And since you can see it's empty because it is actually after drawing that screen, there is no recomposition. There are two reasons, but reason one is that this is a static screen actually, so there is no state to observe, and so that's why no recomposition happens. Except for navigation, there is no state here. And another thing is that I have used immutable list, and I used all the things I described here using remember and everything. So even if you scroll up and down this list, there is no recomposition. So yeah, that's why recomposition section is empty, right? And yeah, you can use layout inspector, and recomposition counts will be shown here, and you can work on it. If you see some section which is recomposing multiple times and it should not that many times, then you can look at the state and optimize it, and then you use layout inspector again to check it. And you can use layout inspector to see various items here, and how they are performing, right, for all the composables. Another way is to use compiler metrics. Now, composable comes with inbuilt compiler metrics, and you can generate a report with it. However, that report is not easily human readable. So my good friend Patil, Shesh Patil, he is also from India. He works at Paytm. He created our own a separate HTML report generator, which uses the Compose provided report generator, and then converts them to human readable with HTML. Right, and I personally prefer using that. So yeah, you can use that, and you can add it to your code base, and like this. So you can just add it like a plugin, and then you can run this command. Now, why release? So composable by default in debug mode, it enables lot of debuggable APIs, including for layout inspectors to work or for UI tests to work. So that's why composables in debug mode perform very bad. In however, it is optimized for release. And whenever you want to check performance, you want to check how the performance affects the user, then you should use release version of your code. So that's why it uses release compose compiler HTML report. If you use debug, there will be a lot of issues reported by this plugin, which is not actionable and which doesn't need any action, right? So yeah, we use release, and that's how your report will look like. So there will be brief statistics. These are the sections that will come to you: detailed statistics, brief statistics, composables report, and classes report. This is the brief statistics where you can see how many skippable composables are there, how many restartable composables are there, and how many are read-only, total number of composables, and all those data you can see, right? Stable arguments, unstable arguments you should act on, and yeah. Now, here's something that is restartable but not skippable. What is restartable but not skippable? That means that composable is marked like the state is not stable enough. It has one of the states that's not stable, and that will trigger multiple recomposition. And as you can see here, I am using list here. One way to optimize it is how I showed earlier, that use immutable list. And if you use immutable list, this issue will not be there. It will show as stability. This parameter will be shown as stable, and yeah, it will be restartable and skippable. So what does it mean by skippable? That unless this item is changed, it should not recompose, right? So that is what is skippable. And similarly, there are multiple other reports you can generate, and yeah. Now, sorry, similarly, there are multiple other sections where you can see details on the data, like what is working, what is not working. And these are some resources that you can look at to learn more about composables. I have a YouTube channel as well, Rivu Talks, where I upload contents and podcasts regularly. You can check it out. I have some courses on Jetpack Compose, KMP, and Kotlin language. You can also check that out. And now I can take questions. And this is the link to the speaker deck. So you can download the PDF version of it. You can have a look at the PDF version of it, although that doesn't have the videos. But yeah, that should help you understand composables. Now I can take the questions.
Thank you so much, Rivu, for all of those insights. There was a lot to gather in this one. Thank you so much.
Thank you.
All right, so I'll just quickly scroll through the comments to see if there are any questions. We haven't had a lot of questions so far. There's just a minor one if you would want to take a look at. This is by Zeus. He's asked if recomposition is equal to redraw or not?
I guess I answered it during the session only. So, recomposition is not necessarily draw. As I said, there are three phases of composition, and based on what's changed in your UI, it might redraw. Uh, like which phase it will execute depends on what's changed on your composition. So, most of the cases it will redraw, but in some of the cases it will not.
All right, thank you. And I think there's another question, which is which scope is available in launched effect?
In launch effect, it uses separate coating scope. It uses a custom coating scope, which is disposable on its own, uh, kind of, and yeah, it is a custom scope basically.
All right. And yep, just a minor question once again from his doesn't get cancelled. I'm not sure how do I interpret that, but yeah.
I asked for if there is any issue with my code, and yeah, that was answer to that. Uh,
Cool. So now we have another question.
can
Can
we at
Yeah, go on,
Yeah,
please.
we can attach viewmodable life cycle to composables, but it is not really needed, right? Why would you want to viewmodel life cycle? Would you want to attach viewmodel life cycle to composable? Composables are very smart. So if something gets changed, it will remove all the UI tree that it has drawn, and there's I don't see any reason to attach memory life cycle to composable. If you want to cancel something, you can use disposable effect, and if you want to run something only once, you can use launched effect. Side effects are very good in this way, so I don't think you need it. Uh, Using composables with fragment is not what I prefer a lot, because what happens is that every time a fragment gets created, then there are the composition tree gets created again and again, right? The themes gets attached again. So I don't really support that. But even if you are using fragment, then also if you navigate out of fragment, then fragment lifecycle can help in that. So fragment lifecycle will call destroy view, and on destroy view, you can remove your compose view, uh, and once compose view is removed, your UI would be maintained by fragment lifecycle only, right? So yeah, again, view model lifecycle is not really needed in composables. Any more questions?
All right. So if you've got any more questions, this is the time to ask.
Yeah, so I am available at Twitter, Mastodon, and basically anywhere you can search my name in Google, and I am pretty easy to find there. Here's my Twitter handle. My DM is open to everyone. If you want to ask something on DM, feel free to ask. If you want to ask something by tagging me, feel free to ask. I love discussing technical things in Twitter and LinkedIn. Mastodon is also here, although I'm not very much active in Mastodon nowadays. But yeah, feel free to ask me anything there as well. And As I said, I launched some courses, code-based courses on Jetpack Compose, Kotlin multi-platform, and Kotlin language. Feel free to check that out. And these are my blogs. Feel free to check that out as well. And here's the slide link.
All right. Thank you, Rivu, for that. And I think we have one more question posted now.
Yeah. Shouldn't view model on clear be called when composable is not visible? So again, you can achieve that with Hilt. Hilt will inject a view model to composable, and every time a new composable is created, it will create a new view model. You can Hilt can handle that in that manner, right? Hilt supports composable. So yeah, whenever your composable is no longer there, Hilt will clear that instance of the view model, so that is taken care of. So that is doable with both Hilt as well as Coin. So yeah, or with both dagger and coin. So yeah, I hope that answers your question. You don't need to manually do it basically.
All
Cool.
right.
It was very nice, and please feel free to share feedback. Feel free to reach out to me with any questions you have. And it was very nice giving a talk at Android Worldwide. This is my second time here. So yeah, thanks.
Thanks a lot, Rivu. And before you go, since we have a couple more minutes, I'm going to take the leeway to ask a question myself.
Sure.
I've just opened up the chat as an attendee, and I'm pasting a bit of snippets. So I hope it comes up. I'm not sure. Oh, okay.
Yeah.
So assuming we have a composable, a basic composable that shows some text, and you
Mhm.
talked about screen effects, and let's talk about, let's say we want to log to analytics whenever the page was viewed or opened. So let's say we have, so we add in a sort of a launch effect where the key is unit because we just want to do it once, even if it recomposes, and we then call the function called on page viewed, which we have passed on to the screen composable. Now, this is a very specific question. It's about how to purely unit test the launched effect. What happens is to, if we only want to fire that event once, but want to unit test it, we sort of also want to verify that when recompositions happen. So basically, if the compositions have been greater than one, the launched effect count should still be one, right? And to
Mhm.
do that within our unit test, we need to recompose whatever the composable is under test. And so
Yeah.
far, I have been unable to change that without affecting some other part of it. For example, the text that we have in this case. And because
Mhm.
of that, it becomes sort of a non-pure unit test and somewhat of an integration
So
test. Because,
the
yeah.
thing is what I said, launched effect or all the side effects, including remember, these will not be recomposed unless your key changes. That is one. And another thing, unless the calling context gets changed, your composer gets changed. So whenever we trigger recomposition from test, right, we are passing a new composer to it,
Mhm.
right? So that will trigger launched effect to be called again. That's what's happening with you, right?
No, not really. So launch defect is now getting called again, and that's the
Okay.
right behavior. But I'm
Okay.
trying to write a unit test for it. So
Can
I'll
you share
paste
the
another
test?
snippet. Yes, sure. The formatting might be really, oh, I think the formatting might be really off. And I think I'll have to send
That's
it
okay.
in two pieces because the minimum length doesn't allow.
Flow. You are emitting something from flow. Uh, yeah.
So basically, let's say we have a state which earlier has string one as the initial string value, and then string
Mhm.
two as the second value that's going to be emitted. Now, our launch defect is only going to be called once, and the unit test is passing fine for this. It's running
Okay.
fine. However, my concern is that this is not an actual pure unit test because this is actually mutating the screen text. This test
Yeah.
is about the page viewed and not the screen text, because if the text would have been an image, then we would have to change this test. So this becomes
Mhm.
an impure test. So is there a way to recompose side effects without having to change other parameters in a composable?
Mm, I will have to think a little bit on it. Uh,
Sure.
let's continue this discussion over Twitter or somewhere. I will have to do a little bit of testing myself to understand this.
Sure. Sounds
Uh,
good. Thank you so much. Uh, all right. I think we don't have any more questions. So we are going to leave everyone for a short 5 minute breather before the next talk. I think,
And yeah, to everyone, my talk was about basics, performance optimizations, and things you should know about composables. Uh, there is another talk by Dinara, and I believe she is going to take you one step above. So please make sure to attend her talk as well if you want to do a lot of performance optimizations in your app. Uh, please do attend her talk, and I will attend myself as well. I'm looking forward to it. Yeah. Thank you.
all right. Thank you. Have a good day, Rivu and everyone, and enjoy
Same
the
to
rest
you.
of
Enjoy.
Android Worldwide.
Bye.